No sense to me. But we're going to not, because we're working with polynomials which have addition and subtraction between their terms. So notice this fraction right here is obtained by taking that remainder and putting it over the divisor. Right? So we're saying, like, if I had to make groups of 4, I could make 3 whole groups and then a fourth of a group. Because if I have one person and I'm trying to make a group of 4, I have 1/4 of a whole group. Does that make sense? So the remainder is written as a fraction. So -6 over your divisor. I'm curious about that, but we'll look at it later. So the reason this works is, remember that the way division works is it's like the opposite of multiplication, right? So if we say that that's our quotient, we are saying that if you multiply 2x plus 7 by the quotient, 6x squared minus 5 plus -6 over 2x plus 7, that is going to be equal to 12x to the third plus 42x squared minus 10x minus 41. And the way it works when we distribute, like this piece, the reason we have to have the divisor in the denominator is because if we were to distribute that, the entire denominator would cancel, and that would give us this -6 that we have left over. Whereas if we just put a -6 there, that's saying that we have -6 times 2x plus 7, which isn't actually in the quotient. So let's do a couple more of these. There's a few other little special cases that we should talk about. One being missing terms. So when we write something in descending order, we can, let's say like this guy. That's in descending order, but notice that we have a degree 3 term and a degree 0 term, and we don't have a degree 2 term and a degree 1 term. And normally that's fine, like we don't have to have all of them accounted for, but when we're doing long division, we have all that subtraction to do. And so theoretically, when we multiply, we could end up with an x squared term or an x term, and we want something to subtract it from. So if I'm going to do, if I do, say, x to the third plus 1 divided by x plus, let's do minus, x minus 1. When I write this, instead of writing x to the third plus 1, I'm going to write x to the third plus 0x squared plus 0x plus 1. So I just put zeros in there. It's like having placeholders. So like if I think of this in terms of place values, this is like a 1 in the thousands place and a 1 in the ones place, right? We wouldn't write that like this. We would write it like this, right? If I wanted 1001. And so those are just like placeholders. They're just zeros, saying that I have nothing in the x squared slot and nothing in the x slot. It is not the same thing to write that, because that's having a coefficient of 1, which isn't the same as a coefficient of 0. So the only purpose those serve is that when we do subtraction, if we have an x squared term to subtract, we have something to subtract it from. So they're really just placeholders. So we're dividing by x minus 1. So what do I multiply x by to get x cubed?
is it x minus 1?
Because that's what I'm dividing by.
Oh.
How do you get the third 0x?
I just put it in there because I put all my missing terms in. So I want it to go 3, 2, 1, 0 in terms of degree. I'm just putting zeros in.
Putting zeros in for what?
For the missing place values. I have a degree 3 term and a degree 0 term, which means I've skipped degree 2 and degree 1.
Oh.
So if you didn't put those in, would you get it wrong, or would you just have to
So
remember
let's do it,
okay.
and you guys can see why they're there. I think once you see how I use them, it'll make more sense that we put them in. So what do we multiply x by to get x cubed?
X squared?
Yeah. So then when I distribute, so when I multiply x squared by x minus 1, I get x to the third minus x squared. Parentheses, subtract. So now when I subtract, x to the third minus x to the third is 0. And then I have 0 minus negative 1 is a positive x squared. If I set this up like this, and I put that x squared there, and I went x to the third minus x squared, notice that those are not like terms. And so I can't subtract them. So we put that 0x squared there so that I have something to subtract that negative x squared from when I do my subtraction. They don't have to be there. You can just know in your head that you're subtracting it from 0. But especially when you're first doing this, kind of lining everything up is a lot easier than trying to figure out what goes with what.
And then do they have to be like terms?
To subtract, they have to be like terms, yeah.
Okay.
Does that make more sense why we have the zeros?
Mm-hmm.
So then we're going to finish subtracting 0x plus 1.
So there's no longer an implied coefficient of 1 on the x squared.
There is an implied coefficient of 1.
So 0
minus negative 1 is positive 1.
So in that divisor, why don't we have an x to the first power?
In the divisor? Here, it's right there.
Technically
Here, I
you do,
mean in
because-
in what we're dividing.
We do it right here. There it goes 3, 2, 1, 0. Yeah.
So that's from only the first one, right? You know, if you had an x, whatever, in the second brackets, would you have to do the same thing?
Uh-huh.
Okay. So that's where your divisor would be. If you had x2, you would have 0x2 and 0x.
If I had x to the third in my divisor?
Yeah. If
Yeah.
so
I
you
just
would
put in
carry
the,
that. Okay.
It's not as important in the divisor, but it's kind of a subtlety to explain why. So I think for now, let's not focus on subtleties. Let's focus on just the basic process. And then as you get more comfortable with these, then we can be oh, well, if you don't put the 0 in there, you can just do this instead. And it's a little easier to do it without putting the missing terms in the divisor than the dividend. But we won't worry about it right now. Okay, let's keep going. Are we good so far? So then we're looking at this guy and this guy, right? So to get x squared, we would have to multiply x by x. And so we have plus x. And then we'll multiply. So x times x is 1x squared. X times negative 1 is negative 1x. Put the whole thing in parentheses and subtract. So again, x squared minus x squared is 0. And then 0 minus negative 1 is positive 1. X plus 1. Then what do I have to multiply x by to get 1x? Just 1, yeah. So plus 1. So we get 1x minus 1 in parentheses subtract. That gives me 0 here. And then 1 minus negative 1 is a positive 2. Now we know we're done because the degree of the remainder is 0 and the degree of the divisor is 1. So plus 2 over x minus 1. What's wrong?
How do you get a positive 1x when you're subtracting 1x from 0x?
You're not subtracting 1x, you're subtracting negative 1x. 0 minus negative 1 is positive 1. See, there's a negative right here, and we're subtracting it.
Oh.
That's also how we got that 2.
Yeah, gotcha.
So the trickiest part of these is usually the signs. You just have to take it pretty slow. Because it's one of those things where if you just look at it and try to do it really quickly, often you'll make an error. Any other questions on this one?
So when we get to what we have on the top,
Yeah.
is that the answer? Do we still have to write it out with the x3 plus 1 divided by x minus 1 equals, and then that's...
No, that's the answer. It's fine.
Okay.
You can just leave it there. Let's do another one. Let's see, that one has all addition. That's so boring. I did that one the other day. Let's see what happens if we do this. Still with the paint. Let's do 15x to the third plus 8x squared plus 11x plus 12 divided by 5x plus 1.
So if you had a 16x plus 1 on the bottom, you can't do that problem, right?
You would get fractional coefficients, which we're not going to worry about. You can still do it, but your coefficients would have to be fractions because 16 doesn't divide evenly into 15. So we've got 15x to the third. Just zoom in here. 15x to the third plus 8x squared plus 11x plus 12. And we're dividing by 5x plus 1. So again, we look at the first terms. So 3x squared, right? So you can look at the coefficients and then the variable factors separately, right? So to get 15, I would have to multiply 5 by 3. And to get x to the third, I would have to multiply x by x squared. So we have 3x squared. And so then we'll do the yes?
Why do you write it over the 8 again? What was that?
Oh, it's just lining up the place values, like the like terms. It doesn't actually matter.
Okay, because so if I write it over the 15.
Yeah, it doesn't matter. Like when you do it with numbers, right, it's like really important that you put these like in the right place value.
Mm-hmm.
So I'm just being consistent with that. But with polynomials, because we have the x and the x squared and the x to the third, it tells us which place value it's in. And so the placement of it isn't actually important. So now we'll do multiplication. So 3x squared times 5x is 15x to the third. And then 3x squared times 1 is positive 3x squared. The whole thing goes in parentheses, and we subtract. So 15x to the third minus 15x to the third is 0. 8x squared minus 3x squared is a positive 5x squared. And one clue that you've made a mistake is if you got like 11 there, 5 doesn't go into 11. That's division we can do, but like I said, we're not going to do ones that end up with fractional coefficients. And so if you end up with something there that 5 doesn't divide evenly into, then like that's a clue that maybe you made a sign error when you subtracted. So plus 11x plus 12. So then same thing. What do we have to multiply 5x by to get 5x squared? So we don't need anything in our coefficient, right? We already have a factor of 5, but we need one more factor of x, so plus x. And then we'll multiply. So x times 5x is 5x squared. X times 1 is 1x, which you can just write as x. But if you're more comfortable actually seeing that number to do your subtraction, then go ahead and write it. Make sure you have those parentheses. That's what helps us distribute that subtraction. So we have 11x minus 1x is 10x, and then plus 12. So now we're looking at 5x and 10x. So what do I have to multiply 5x by to get 10x? Just 2. So plus 2, then multiply, we get 10x plus 2, in parentheses, subtract. And we get a remainder of 10. And it's tempting to keep going because we're like, oh, 5 divides evenly into 10. But remember that we want to look at degree, right? There's nothing I can multiply x by to get rid of a factor of x to get 10. And so that's just our remainder, which we'll put up here, plus 10 over 5x plus 1. Do you guys want to do one more?
Yes, please.
Okay. Oh, this is a good one. Let's do 8x to the fourth plus 10x squared plus 2x plus 9 divided by 4x plus 2. So the first thing I check for is if I have missing terms, and in this case we do, right? We're missing a degree 3 term in our dividend, right? It goes 4, 2, 1, 0. We want it to go 4, 3, 2, 1, 0. So we're going to put a 0 in. So this becomes 8x to the 4th plus 0x to the 3rd plus 10x squared plus 2x plus 9. And we're dividing by 4x plus 2. So what do I have to multiply 4x by to get 8x to the 4th?
Is that 2x squared?
Uh-huh. Oh, 2x to the 3rd, actually.
Right.
So then we'll multiply. We have 8x to the 4th plus 4x to the 3rd. So 8x to the 4th minus 8x to the 4th is 0. And then 0 minus 4 is a negative 4. So we have negative 4x to the 3rd plus 10x squared plus 2x plus 9.
Okay, I have a question that might seem silly, but if we have it written off to the side like we normally do at 0 minus and then the parentheses forward,
Yeah.
also in minus, wouldn't that?
So it's 0 minus 4. It's not that's not negative 4, it's plus 4.
Oh, gotcha.
So we're subtracting a positive 4.
Okay.
So far so good?
Yes.
So what do I have to multiply 4x by to get negative 4x to the 3rd? How many more factors of x do I need? 2. So negative x squared. So negative x squared times 4x gives me negative 4x to the 3rd. And then negative x squared times 2 gives me negative 2x squared. We're subtracting that whole thing. So Ben, this is where you'll subtract a negative. So negative 4x to the 3rd minus negative 4x to the 3rd is 0. And then 10x squared minus negative 2x squared is a positive 12x squared. And just like we did with exponents, like Ben was saying, you can like write this like 10 minus negative 2 over here if you find yourself making mistakes with the subtraction, like with the signs. Okay, so then what do we have to multiply 4x by to get 12x squared?
3x.
Yep. So positive 3x. So that gives me 12x squared. And then a positive 6x. So when we subtract, we have 12x squared minus 12x squared, which is 0. And then 2x minus 6x is going to be a negative 4x. And then plus 9. So what's my last term going to be up top?
Negative x in second.
So I'm looking for what I need to multiply 4x by to get negative 4x. Negative 1, right? So negative 4x and then minus 2 9 minus negative 2 is a positive 11. And so we have plus 11 over 4x plus 2. If you want to think about it in terms of like just those 3 steps, right? So like what do I have to multiply by? That goes up top, and then you multiply and subtract. And then you're just repeating those 3 steps over and over again. If you find yourself getting overwhelmed by how much stuff there is, try to realize that once you get to this point, you can almost like just pretend none of that's there. It's like you're starting a whole new problem every single time, like when you're done subtracting. So like then when you get to this point, it's like none of that matters anymore, and you're starting a whole new problem. So think of it sort of in pieces like that rather than like all at once, because it can be a little overwhelming. There's like a lot going on. But if you think of like doing those 3 steps repeatedly, and each time you start those 3 steps again, like you're kind of starting like a new problem, then it's a little easier to kind of break it down and not get overwhelmed by all of it. Other questions on this process? So on the online homework, you can still get back into it. You just click like, when you're past the due date, like it pops up this thing that's like, says it's past the due date, and then it says like, do you want to improve your score? Like there's a button for like review, and there's a button for improve my score, and you want to click the improve my score button. Otherwise, it just like, it has you do the problems, but it doesn't record your score for it. Like there's review mode where you can do all the problems you want, but it doesn't actually like record it. Yeah. So you want to click the improve my score button, and it'll let you back into the assignment, and you can finish that up and get full credit for it. So be sure to go back and do those division problems that we said you didn't have to do on Friday. And then I printed out just that second page of Friday's worksheet, so you can do that tonight as homework as well. Okay. Today's lecture is, there's kind of a process, and if you think about it in smaller pieces, then it's a lot easier than just looking at it and trying to like poof, like know the answer. So there's 2 ways to do these problems. You can do it additively or subtractively, which means that I could find the area. Let me get a good color here. So I could find the area of this rectangle, this rectangle, this rectangle, this rectangle, and then this square, and I could add all those areas up. And that would give me, so if I did that one, plus that one, plus that one, plus that one, plus that one, that would give me the total area of the shaded region. You guys agree?
Yeah, but you don't have enough data to do that.
Well, we do, but we'll get to that in a second. So that's the additive approach. Then the other approach is to say, I'm going to find the area of this whole thing, so this whole square, and then from that I'm going to subtract. So it's like you have a piece of paper and you cut out the corners. So we subtract those 2 areas, or 4 areas, and then again we're left with just the area of the shaded region. So we can either build up the shaded region, or we can start with a bigger shape and cut it down. Depending on the problem, one is usually more efficient than the other one. In this case, I would do this subtractively, and the reason sort of quick way to tell is by figuring out how many areas you have to get. So if I was going to do this additively, I'd have to add up 5 areas. Whereas if I do it subtractively, I can just find the area of the big thing and then subtract 4 areas, but they're all the same. So I'm really just finding 2 things. So we always start by writing down our plan in words. You guys will want to skip this step, and you'll roll your eyes at me and be like, and skip it. But it's actually the most important step because it tells you what you're finding and what method you're using so you don't mix it up halfway. I've seen many times people like want to do it by adding everything up, but halfway through they start subtracting stuff because that's how they did the last problem. So what we're going to do here is we are going to find the area of the whole thing. And then we're going to subtract the corners. So the whole figure is a rectangle. I mean, in this case, it's a square, but we'll pretend we don't know that. And we're going to do length times width. And then each of the corners is also a rectangle / square. So we're going to have length and width. And we're going to multiply that by 4 because there's 4 of them. So when we get to this part, what we're doing is filling in the length and the width. So what we're looking for are just basically how long are these specific lines. So the first thing I want is the length of that entire figure. I can't stress enough how helpful it is to actually put your pencil down and trace the line that you're trying to find the length of. How long is that line?
X minus 8.
From here to here?
I'm going to say that. That's my best guess.
So,
X plus.
it's just X. Like, right? You guys see it?
Yeah.
Like from there to there is labeled as X, right? So the length is X. And then what's the width from here to here?
X.
Also X. Next, we want to look at a corner. So we want the width of a corner, which is from here to here. What is that distance? 4. And then the width is from here to here, which is also 4.
But you said width, that would be length. You're putting, you said, never mind. I don't know.
So in general, the length is the longer one and the width is the shorter one. But they're the same in this case, so it doesn't matter. So the key to this is thinking in 1 dimension, not 2, right? So like it's tempting to like look at one of those corners and be like 16, which does end up being the area of it. But we want to think in terms of finding a length and a width. I mean, this one was fairly simple because I labeled everything that you need, so we didn't have to do much work, although we tried to do more work than we had to. But you want to think in 1 dimension. So when you fill in each of those sets of parentheses, you're looking at the length of just a line. And when you multiply them, that's what gives you your area. But you don't want to try to like look at the whole thing all at once.
So you could do 64, 2x minus 64.
So x times x is x squared, and then that's our final answer. But
Seems like a lot more work to what I can just do in my head. But I guess it's
okay, so let's do the next one and we'll see. So do you guys want to add up? So our choices here are to add up these three pieces or to find the area of this whole thing and then take away the area of that guy. I would subtract as well. Right? Whoa. There we go. So we're doing the entire rectangle minus the bottom right. And the way that you write these in words is totally up to you. I just try to write something that makes it really clear which part of the figure I'm actually talking about. Like if we were like entire rectangle minus little rectangle, well, there's lots of little rectangles, right? So you could also say like entire rectangle minus unshaded rectangle. So we have for the entire rectangle, there's a length and a width, a length and a width. So what's the length of that entire rectangle? So that's from here to here.
15.
Yep. And then the width is from here to here, which is 9. Good. So now we're looking at just the rectangle in the bottom right. So the length from here to here is 4. And the width from here to here is x. Well, I don't know what 15 times 9 is, jeez. It's 90 plus 45 is 135, yeah. Minus 4x. So far, so good? Okay, so this one, again, we have two choices. We could just find the area of this one rectangle, or we could find the area of this entire thing and then subtract this rectangle, and this rectangle. Which one do you guys want to do?
Add one.
Yeah, let's just find the area of the one rectangle, right? Because it's just like, if you think of how many shapes you have to find areas for, finding the area of that one shaded rectangle is a lot less than finding the area of the whole thing and then subtracting 3 other areas, because that's finding 4 areas as opposed to 1. So we are just finding the area of the shaded rectangle. We don't have to add it to anything. We don't have to subtract anything because it's just one rectangle that's shaded. So we're going to look for a length and a width. So length from here to here, what is that length?
Would that be x minus 2?
Yes, very good. Because this whole thing is x, and I'm cutting off this piece, which is labeled as 2. You guys see it? So think of it as like a rope, so we can add 2 pieces of rope to get a longer piece, or we can cut pieces off to get a shorter piece. So my length is x minus 2. And then my width is from here to here. So x minus 6, yep. Remember that when you're doing this, you're thinking only in one dimension. So when we're finding the width, the up and down, you're only looking at things that are like vertical lines that are labeled. Like what's labeled going this direction is going to have no bearing whatsoever on finding the length of that vertical line. Yes?
So it doesn't really matter, let's say if you like got the length in with mixed up.
Oh yeah, they don't matter. As long as you just do two separate dimensions. So here we said x is from here to here, and then we have to cut off that piece in order to get the length we want. So x minus 6. And then let's simplify that. So we get x squared minus 6x minus 2x plus 12. Good. 8x plus 12. And I should say, like, the two options for how we find the area, they're both correct. Like, you would get the same answer if you'd found the area of the whole thing and then subtracted off all those unshaded rectangles. It's just sometimes one of them's way more work than the other. Okay, next one. So in this case, we really only have one option because we don't have a formula for the area of like a tire. Right? Like we have the formula for the area of a circle, but like we don't have any formula that will get us, whoops, I don't want that. Whoa. We don't have a formula that gets us the area of a shape that looks like that. So the only option we have is to find the area of that big circle and then cut out the area of the smaller circle. You guys know how donuts are made?
Yeah.
How?
Cut the center.
Yeah, you like cut the center out. You'd be surprised how many people don't know how, like I used to use this as an example all the time, like how donuts are made.
Well, yeah, then it's not a donut, it's a friggin' jelly friggin' thing.
So one of my students, I was like, so do you know how a donut's made? She's like, well, yeah, you know, you just like make it. And I'm like, so like, you know, like, which is how bagels are made, incidentally. So it's not like that out of the question. I was like, but what about donut holes? How do you think they make donut holes? And she's like, you just roll a little ball. And I'm like, I don't think that they'd make the donut holes if they weren't actually the holes from the donuts.
Just because it's faster.
So the way that you make a donut is what we're going to do here, is you make like an entire circle of dough.
We're all going to go to Granny's after this.
And then you cut out... Then you cut out the donut hole. And so that's what we're going to do here, is we're going to do the big circle minus the little circle. So big circle minus little circle. And so the area for a circle is pi r squared. So we have pi and then something squared. So we still have this set of parentheses where we're just finding the length of one line. And pi times something squared. So the first thing we want is the radius of the big circle. The radius of a circle is the distance from the center of the circle to any point on the outside of the circle. So in this case, it is what?
Plus B.
From here to here?
A squared. Or just A.
It's just A, yeah.
Sorry.
And then the radius of the little circle is going to be from the center to a point on the edge, so B. So pi a squared minus pi b squared. And we're done.
But it's not really a solution to the problem. I mean, it's a solution, but it doesn't tell you, like if you flip back over here,
Yeah.
135 minus 4x, well, you still don't know what x is.
That's true. So that's the point, is that we are potentially in a situation with changing variables, right? So like, you know, suppose this is a tire. Well, you could have like 17-inch tires, you could have 18-inch tires, and this formula allows us to find the area of the tire regardless of what.
And then you can input whatever number.
Right, exactly. So it's just like the formula for like the area of a circle. Like we don't know what r is when we talk about the like pi r squared being the area of a circle. But if somebody gives us a circle, then we can get that one piece of information and figure out the area. So same deal here. We're building a formula for the area of that tire, so to speak, or donut. And if somebody actually hands us the donut and we can get those two measurements from it, then we can just plug that into our formula and we know the area. So that we don't have to...
We're trying to get solutions, and I'm like, well, this isn't solving the...
So we are writing expressions.
Right, okay. I get what you're saying now. Sorry, I was just...
No, you're fine.
That was confusing me, so I'm like, where's the solution?
So the solution to a math problem isn't always going to be a number.
Right, that's the thing to get over.
Yeah. That's why we don't put like lines. Like remember back in the day your teacher always gave you like lines to write your answer on. Like that's sort of out the window now because this like whole thing is the solution, right? And so we can't just write it all on one little line. Okay, let's do the next one. So in this case, again, we could find the area of the square in the middle, or we could find the area of the whole thing and then subtract all of these. What do you guys want to do? Yeah, let's just do the one rectangle. I think in general, if there's a single rectangle that's shaded, you should always just find the length and width of that one rectangle. So we're just doing the shaded, in this case it's a square. So we need a length and we need a width. So here's my length from here to here.
So 12 minus x squared.
Very close. It is 12 minus 2x. So one thing to keep in mind is along the same, in the same dimension, so if you're going all horizontal, you're only doing addition or subtraction. So we're doing 12 minus x and then minus another x. The only way to get x squared is to multiply x times x. So we only do multiplication between two dimensions. Along a single dimension, we always do addition, subtraction. So the only time the multiplication comes is when we find the area. We're multiplying like horizontal times vertical. But if we're doing any calculation to get just one line, then we always do addition, subtraction to get there. So we started with this distance, and then we cut off the two ends.
Because if the whole thing was shaded, it'd just be 12 times 12, right?
Right, if that whole square was shaded, it would have an area of 144. So we have 12 minus 2x, and we can kind of see looking at this that it's symmetric, right? That this is actually a square. So this distance is going to be exactly the same. So 12 minus 2x. And then we'll distribute to simplify that. So 12 times 12 is 144 minus 24x minus 24x plus 4x squared. So 4x squared minus 48x plus 144. And I just put that in descending order only because it is somewhat more usable in descending order. We'll see tomorrow when we start factoring that all the tools that we have for factoring are based on our polynomial being in descending order. So it's not that it's more correct, it's just more like usable in other situations to have it in that order. How are we doing? Ready for the last one? So this last one is exactly the inverse of the one we just did. So this one, the only thing that was shaded was that middle square. And on this one, the only thing that is not shaded is the middle square. So we're doing essentially the same thing, except instead of just finding the area of the middle, we are going to find the area of the entire thing. So entire square minus the unshaded square. So we're finding this whole thing, and then we're cutting out this one. So we're making a square donut, basically. So we need a length and a width minus length and width. So from here to here is 9. And from here to here is 9. And then we want that unshaded square, so we want this distance right here, which is going to be what?
X minus.
9 minus 6.
Very close. So yeah, so we need to subtract 2x because this whole thing is 9, right? And then we're going to cut this guy off and cut this guy off. It looks different than the last one because I didn't draw all the lines. But this is the same exact picture as the last one. It's just like shaded differently and labeled. The labeling looks different. So like if I could go back here and if I change this, like these to 9s, it's the exact same shape as this. So this distance right here is going to be 9 minus 2x. And then this one, it's symmetric, and so it's going to be the same. So 9 minus 2x.
Well, how'd you get the 2?
So to get that length, we start with the whole thing. And then I have to cut off this piece, which is x. And then I have to cut off this piece, which is another x. So essentially we did like 9 minus x minus x. And then combine like terms. So it's because we cut off 2 ends. So now we're going to simplify. We get 81 and then minus, and when we multiply, remember that this needs to be in parentheses because we haven't addressed all the operations outside the parentheses yet. We haven't addressed that subtraction. And so we get 81 minus 2x, whoa, not 2x, sorry, 18x minus 18x plus 4x squared. And then we'll combine like terms inside the parentheses. So 81 minus 36x plus 4x squared. And now to get rid of the parentheses, we're going to use that negative sign. So we're going to distribute the subtraction to every term in the parentheses. So I have 81 minus 81 plus 36x minus 4x squared. So that simplifies to negative 4x squared plus 36x. So those are basically all the different types of shapes that you're going to see. Again, the key is really just coming up with a plan and then looking for the specific lengths rather than trying to find the area all at once.
Is triangle still the same base, equals 1/2, or minus 2? Or the formula, is it still the same formula?
Yeah,
Base
so
equals
the
height
area of
minus
a
2, or
the area of a triangle is half the area of a rectangle. So if this is base times height,
divided by 2.
then if I want to get the area of this triangle, I just divide the area of that rectangle in half. So 1/2 times base times height. But we don't have any triangles.
Not no triangles.
In practice,